Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with Chapter 8. This is the last section of the chapter, which this whole chapter has been about exponents. 8.6 is today's lesson, and the name of this lesson is Exponential Decay Function. Our essential question is, what is exponential decay? So this idea, we talked about exponential growth before, which was basically, a quantity increasing by a certain percentage every unit of time, and it gets really big really fast. This is a similar idea, except exponential decay is going to be something that's going to get small really quickly or really fast. And it's very useful for stuff like electronics, measuring their value after a year, or a car. Basically, after every year that you have your car, it's going to decrease in value, but it's not going to decrease by a consistent amount every year. It's going to decrease by a percentage every year, okay? Same thing with electronics. So let's get right into this. So exponential decay is a quantity that decreases by the same percent in each unit of time, all right? And we have our exponential growth. Actually, it says exponential growth here. This is actually exponential decay, though. Exponential decay model. So this is very similar. The original exponential growth was y equals c times 1 plus r all to the t. But what's the difference between this one and the new one? Well, you can see before it was 1 plus r, and this time it's 1 minus r, okay? So we have some similar kind of ideas here. So c is going to be still our initial value. C is still our initial value, all right? 1 plus r was our growth factor, so what do you think 1 minus r is going to be? It's going to be our decay factor. 1 minus r is our decay factor. R for growth factor, or for growth, the growth model was percent of increase, so r for decay is going to be the percent of decrease. Okay, so let me actually, and one thing we need to write here is that 1 minus r is whatever is in parentheses. It's going to be our decay factor. And our percent of decrease is how far the decay factor is from 1. That's going to be our percent of decrease. And t, like we said before, is going to be equal to our time. Okay? So we're going to do some actual word problems here. We're also going to be getting some practice with identifying the decay factor, percent of decrease, percent of increase, and that kind of stuff. Okay? All right, example 1. Your iPad was originally $200. Like all electronics, it loses value every year. It depreciates. So appreciates means it gains value. Depreciates means it loses value at a rate of 12% per year. What will the value be in 4 years? Okay, so let's, we're going to use the formula. So it's going to be y equals c times 1 minus r all to the t. So we need to find our initial value, our decay factor, percent of decrease, and time. So what is our c? What's our initial value? What do we start with? The iPad was originally $200. That's our c. What else do we know? Well, one thing I forgot to put here is convert to a decimal. The percent of decrease needs to be a decimal. Convert to a decimal. Okay, so C is $200. What's our R? Do we know our R? Our R is 12%. And what's that as a decimal? It's 0.12. And what's our time for this problem here? Our time is 4. I should have actually asked, are we looking for the ending amount, which is y, or are we looking for the initial amount, which is c? Well, if it was originally $200, we know what c is, and we're looking for y. We're looking for the ending amount, the ending cost or value of the iPad, right? So we're not looking for the initial amount here. All right, let's plug in what we know now. So we have y equals c was 200 times 1 minus our r, which is 0.12, all to the t, which was 4. All right, and I'm going to simplify what's inside the parentheses a little bit here because I want you to be very confident with this kind of stuff here. So 1 minus 0.12 is 0.88. all to the fourth. So this is the same thing. Depreciating at a rate of 12% a year is the same thing as multiplying by 88%. It's the same thing as multiplying by 88% every year. Okay, it's like we're taking off 12% by multiplying. We're saying we're multiplying it by 88% of its original value every year, which means you're taking off 12%. Okay, so I want you to be comfortable that it's a similar thing. Is instead of subtracting 0.12 from 1, you can just multiply by what percent is left over every year. Okay, so if you plug this into your calculator, you should get y. It's approximately $119.94. All right, and there's our answer. Okay, so a couple things to keep in mind here in this box here. When the factor is greater than 1, it's going to be growth, and when it's less than 1, it's going to be decay. All right, so we're going to do this example 2 together. We're actually going to try a couple. We're going to try a couple more of these types of problems later to make sure we're comfortable with it. Okay. So it says classify the model as exponential growth or exponential decay. Identify the growth or decay factor and the percent of increase or decrease per time period. So we're going to have to solve for 3 different things here. So first thing we're going to identify whether it's growth or decay. We're also going to identify the growth factor or decay factor. We're also going to do percent of increase or percent of decrease. Okay, so we need to identify all 3 of these things. The one thing to keep in mind is that if it's growth, it's automatically going to be growth factor and percent of increase. If it's decay, it's automatically going to be decay factor and percent of decrease. You're never going to have growth and then decay factor and percent of increase. It's never going to be a mix. If it's the first one, it's going to be all the first one. If it's the second one, it's going to be all the second one. Okay, so just keep that in mind. So, first of all, is this growth or decay? So the only thing we need to look at is what's in the parentheses here. We just need to look at what's in the parentheses here. We have 2/5. Now, if it's bigger than 1, it's going to be growth. If it's less than 1, it's going to be decay. So is 2/5 bigger than 1 or less than 1? It is less than 1, right? So that's going to be 2/5 is less than 1, so it's going to be decay. It's going to be decay. Because, and I want you to put this here too, is 2/5 is less than 1. That's why. That's why it's decay. 2/5 is less than 1. We're multiplying by a percent less than 1 every time. So because it's decay, what's the growth factor? What's the decay factor? We don't know. It's not going to be the growth factor. Well, it's literally whatever's in the parentheses here. So the decay factor is going to be 2/5. Literally going to be 2/5. But another thing I like to do here if I have a fraction is to convert it to a decimal to help me figure out what to do later. Okay, you'll see why in a second here. What's 2/5 as a decimal? If you do 2 divided by 5, you're going to get 0.4. Okay. And we know it's decay factor, and it's also going to be percent of decrease. So, the decay factor or growth factor is how far from 1 the decay factor is. How far from 1 the decay factor is, all right? So we have 0.4. We're going to use 0.4, not 2/5. So I'm always going to do the bigger number minus the smaller number. So what number is bigger, 1 or 0.4? 1 is bigger. So I'm going to do 1 minus 0.4, which equals what? That's 0.6. Okay? It's 0.6. So what's 0.6 as a percent? What's 0.6 as a percent? That is 60%, right? So if we're multiplying by 40% every time, that means we're taking away 60% every time. So this is going to be 60% decrease because we're multiplying by 0.4 every time. We're taking away 60% every time. Okay? So always take the bigger number minus the smaller number and then to convert that number to a percent by moving a 2 to the right. We move this decimal 2 to the right to get 60%. Okay? So that's how we do those. We'll come back to, we're actually going to do 3 more examples of this after we do the next couple examples. And yeah, we'll do more examples like this in a little bit here, okay? All right, example 3. You buy a used truck for $20,000. It depreciates at a rate of 15% per year. Find the value of the truck in 3 years. Okay, we're going to use y equals c times 1 minus r all to the t. All right, are we looking for c, or are we looking for y? Are we looking for the original value, or the initial value, or are we looking for the ending result? We're looking for the ending result. We're looking for y. We're looking for the final value of the truck after 3 years, right? So that means the 20,000 is going to be our c. What else do we know? Our t is 3 and 15%. Plus 15% is a decimal. Move the decimal 2 to the left. It's going to be 0.15. So we're going to plug this in now. So we have y equals 20,000 times 1 minus 0.15 all to the third power, which is going to be equal to y equals 20,000 times 0.85 all to the third. And if we plug that into our calculator, we're going to get y is approximately $12,282.50. All right, so after 3 years, this is really kind of disheartening, but it is how it is that after you buy a used truck for $20,000, after 3 years, it's going to be worth a lot less money. So that's how it works. Okay, example 4. You know, I don't actually like example 4 all that much. I think we did a couple examples that were fine, so we're going to move on to the last 3 examples here. So you're actually going to write a couple more examples here, so save some room. We're going to write 3 examples here. Okay, so example 1 is going to be y equals 2 times 1.5 all to the t. Number 2 is going to be y equals 19 times 5/6 all to the t. And number 3 is going to be y equals 200 times 0.99 all to the t. Okay, and we're going to be looking for growth or decay. We're going to be looking for the growth factor and decay factor. And we're going to be looking for percent of increase or percent of decrease. And these are just like the other example that we did before, this one up here, number in the blue. Okay, so why don't you guys see if you can try these on your own and see how you do. Okay, we'll go through them in a second. And just be aware these might be a little challenging because we haven't talked about some of this stuff, but do the best you can, see how you do. All right, number 1. We have y equals 2 times 1.5 all to the t. So first things first, is this the growth or decay, and how do you know? Well, we only look at what's in the parentheses here. It's the only thing we look at for these kind of problems here. We have 1.5. Is that bigger than 1 or less than 1? It is bigger than 1, so it's going to be growth, because it's bigger than 1. And the reason why is 1.5 is greater than 1. All right, so what's the growth factor then? If it's growth, it's automatically going to be growth factor. Well, it's going to be whatever's in the parentheses, and whatever's in the parentheses is just 1.5. That's our growth factor. All right, now we need to find the percent of increase. So we're going to take, remember, this is how far the growth factor or decay factor is from 1. So we're going to take the growth factor in this case, which is 1.5. Which number is bigger, 1.5 or 1? 1.5 is bigger, so I'm going to literally take the bigger number minus the smaller number. 1.5 minus 1 equals what? 0.5, right? Now let's convert that to a percent. Move the decimal 2 to the right. It's going to be a 50% increase, right? 1.5 is bigger than 1. It's going to be a growth. It's going to be a percent of increase. So it's going to be 50%. Okay, does that make sense? Because basically we're multiplying by 150% every time. 1.5 is 150%, right? Up here, this is multiplying by 40%. So it's decreasing by 60%. So however far away from 1 it is going to be how much it increases or decreases by. This is 50% above 100, so it's going to be a 50% increase. This was 60% below 1, which means it's going to be a 60% decrease. All right, let's try number 2 and number 3 now. Number 2, We have, we're looking at the 5, 6. That's going to tell us whether it's growth or decay. Is 5, 6 bigger than 1 or less than 1? It's less than 1, so it's going to be decay. And because the reason why is 5, 6 is less than 1. So if it's decay, it's automatically going to be a decay factor, which means it's going to be just 5, 6, whatever's in the parentheses. And then we need to convert that to a percent, actually. So what's 5, 6 as a percent is actually divided, or as a decimal, that is. Divide it by 5 divided by 6, you're going to get about approximately 0.83. So now we need to remember the decay factor or the growth factor is how far from 1 it is, how far from 1 the growth factor or decay factor is. So what number is bigger, 1 or 0.83? 1 is, I'm going to do 1 minus 0.83, which equals 0.17. Convert that to a percent, move it 2 to the right. We're going to get approximately a 17%. It's decay, so it's going to be a 17% decrease. That's our percent of decrease, right? It's 0.83, which is, we're multiplying by 83% of the original value every time, which means we're taking away 17% every time. All right, last example. 200 times 0.99 all to the t. First things first, is it growth or decay? Is 0.99 above 1 or less than 1? It's below 1, so it's going to be decay, because 0.99 is less than 1. All right, what's the decay factor? If it's decay, it's going to be just 0.99, whatever's in parentheses. It's already a decimal, so we don't need to worry about that. Now we need to convert, now we need to figure out what percent it is away from 1. So is what number is bigger, 1 or 0.99? 1 is bigger, so we're going to do 1 minus 0.99, which equals 0.01. Convert it to a percent, move it 2 to the right. That's going to be a 1% decrease. And that's going to be our answer. Okay? And 0.99 is multiplying by 99% every time, which means we're decreasing it by 1%. This one, where it was 83%, we're decreasing by 17%. This one was 150, we're increasing by 50% every time. Okay? All right, and that is all I have for you today. Thank you for watching. Have a great day. We will talk soon.